A pratin coal attempts to lure a predator away from its eggs by crouching on the ground with wings outstretched as though unable to fly. These sockeye salmon are nearing the end of their long journey upstream to reach the spawning grounds where they will lay their eggs, perhaps on the very stretch of river where they themselves grew up. How do these animals know how to behave? Do they have to learn these skills, or is their behavior shaped by heredity, in other words, innate? The part these two influences, nature and nurture, play in behavior has fascinated man for centuries. Perhaps by looking at the behavior of other animals, we may learn more about ourselves. During the earliest stages of an animal's life, it's often the simplest behavior which is the most important for survival. A kangaroo leaves the womb while still an embryo and makes a remarkable journey up to its mother's pouch. Still blind and deaf, its bud-like front legs are strong enough to pull it upwards through the fur, guided by smell. There's no time for mistakes on this 3-minute journey. Once it reaches the pouch, it'll clamp onto a teat and remain suckling for the next 7 months. When an animal has to get it right first time, the behavior is usually innate. It works well provided circumstances do not change suddenly. Birth is a time when mistakes could be fatal. A newly born wildebeest calf tries to struggle to its feet to suckle immediately after birth. If it fails to do so, it'll probably fall victim to predators. Wildebeest live in large herds, and it is obviously important that the mother learns to recognize her offspring after birth. She licks her calf and learns to recognize its smell and the sound of its cries. But this learning ability is only restricted to the first 5 minutes after birth. If she's separated from her calf during these vital minutes, she will always reject her offspring in the future and refuse to suckle it. The young calf learns to recognize its mother in the same way and always tries to keep up with her. This limited type of learning is often called imprinting. These goosander chicks are imprinted on the first moving thing they see, normally their mother. They learn to recognize her within the first day of hatching, and subsequently they will follow her wherever she goes. They'll even hurl themselves over a 60-foot drop to reach her. Luckily, they are well padded for a soft landing. Immediately, they make their way towards the river, where their mother is calling them to join her. They are already able to feed themselves, but they will stay with her for another month to learn the finer points of feeding. Birds which nest well away from predators produce young which are almost helpless, but the chicks have one innate response. They beg with a wide-open gape when the parent approaches the nest with food. As long as the gape is there, the parent will ignore all other clues and simply stuff the chick with food. This innate response to a begging gape is used by nest parasites to their own advantage. After heaving the dunnart's eggs out of the nest, a cuckoo chick presents a super gape, which the poor foster parent finds irresistible. She slaves tirelessly to feed the usurper. Perhaps if the dunnart had been able to include size as an additional clue to the identity of her own offspring, cuckoos wouldn't be around now. We all take it for granted that animals know what to eat. The hummingbird's choice of food is innate because it's specially adapted to probe for nectar while hovering on the wing. It would only be worse off if it tried to feed on anything else. But for omnivores, such as baboons, there's a great deal to be gained from curiosity and trying out new foods. Young baboons learn how to manipulate food and what is edible by imitating their elders. As with humans, the older members of the troop tend to be more conservative, while young baboons are constantly trying out new objects for edibility. Perhaps that is how meat entered the diet of the whole troop. Learning gives baboons the flexibility to cope with sudden changes in the environment, such as drought. They can always switch over to another food. The baboons in this troop have learnt to turn over stones to search for termites. It isn't long before the observant youngster follows its mother's example. Many predators learn to pick out clues such as movement and color contrasts when searching for their prey. As a result, many prey insects remain motionless, breaking up their outline and blending in with the background. So this blue tit has to learn to look for new clues. It takes a long time to find the first camouflaged caterpillar, but once it's found one, it is able to spot others with increasing ease. The bird has got its eye in and learnt what to look for. But some insects have turned the bird's ability to learn simple visual patterns to their own advantage. These cinnabar moth caterpillars have acquired an unpleasant taste as a result of feeding on ragwort. Once a bird has sampled a cinnabar and rejected it, it'll always associate the color pattern with an unpleasant experience. The same principle of warning coloration is used by many other poisonous insects, such as the caterpillar of the monarch butterfly, which feeds on toxic milkweed. But warning coloration will only work as long as the predator can learn and remember a warning pattern. Many animals have to learn a new skill before they can feed successfully. Squirrels have to practice cracking open hazelnuts. But surprisingly, the squirrel's hoarding of nuts beneath leaves is under innate control. If a squirrel is given nuts away from its native woodland, it will still go through the motions of burying them, carefully covering them with leaves and patting them down. The result is far from desired, but the squirrel is unable to alter its behavior to cope with the new surroundings. The Pacific sea otter collects abalones and sea urchins from the seabed. At the same time, it selects a small stone and carries it up to the surface. It uses the stone to smash open sea urchin shells laid across its chest. Now, this learned behavior has become almost universal among Pacific sea otters. These cheetah cubs may look as though they're just romping about aimlessly, but these chases actually involve many of the elements adults use when hunting. Play is rather like practicing for adulthood through fun and games, and most young mammals do it. By the time the cubs are nearly a year old, their mother may bring them a gazelle fawn to play with. The ability to chase and knock the fawn down is already there, but the cubs still haven't learned what to do with the fawn once they've brought it to the ground. With more practice and experience, they will soon be able to make a kill of their own. In Britain, blue tits accidentally discovered the cream in milk bottles when frost forced off the tops. A few birds learned that they could peck through the foil to reach the cream by peeling it back as though it was bark. The habit spread across the country as other birds imitated the pioneers until it became commonplace. Many birds are able to learn entirely new patterns of behavior. Marabou storks are normally only scavengers, feeding alongside vultures on a carcass. But during the dry season, such dense clouds of quelea and doves come to drink at the waterhole that the marabou only has to open its beak and charge, and some unfortunate bird will be bound to end up inside. It has learned the skills of a hunter. Japanese macaques have had to retreat to the harsh mountain regions of Japan to escape man. They've not only learned to forage for roots and berries beneath the snow, they've also learned to take advantage of the hot springs of the region. Japanese macaques are probably one of the few animals to take a hot bath, apart from man. It's now part of their daily ritual to groom and bathe together in the steamy water. In other words, it has become part of their learned culture. Learning can also involve the suppression of innate behavior. Like most wild animals, these great white pelicans once feared man and avoided him. But continual exposure to the fishermen has taught them that they can come to no harm. In fact, there are distinct advantages in keeping as close to the boats as possible. This eider duck is trying to draw the intruders away from its nest by pretending to have a broken wing. But the people aren't interested in the birds or their eggs. All they want is the warm down that the eiders use to insulate their eggs. But the eider still persists in its wing display. This actually makes it easier for the down collectors. Most defensive behavior, such as the eider's wing display, is innate because flight is only effective if it is fast. An innate response is far more likely to guarantee a quick reaction than a learned one. Astonishing migrations are found throughout the animal kingdom. Every 2 years, these green turtles migrate several thousand miles from their feeding grounds off the Brazilian coast to lay their eggs on Ascension Island. Ascension is a mere dot in the ocean. Yet they not only manage to locate it, they also succeed in finding the very beach where they themselves hatched out 20 years before. It's believed that they find their way by being imprinted on the taste of the water around Ascension. Once the female has laid her final batch of eggs, she returns to the sea. The young turtles hatch out almost 2 months later. It's vital that they emerge at night. Daytime temperatures would kill them. This is ensured by very simple innate behavior. If the turtle encounters sand above 86 degrees Fahrenheit, it stops moving. This will only happen during the day. At night, the temperature of the sand falls, and the turtle is stimulated to crawl upwards until it breaks through the surface. The next problem for the hatchlings is to find their way down to the sea in the dark. It's believed that they are able to distinguish a paler band of sky above the sea because it acts like a huge mirror, reflecting any light. It is an innate response which causes the turtles to head towards the light and the sea. Equivalent navigation skills are also found among many insects. This Bembex wasp has the non-stop task of feeding her grubs within their tunnel nests. Each time she leaves a nest, she carefully closes it up again so that it becomes invisible. Then she hovers and circles over the nest for a few seconds, memorizing all the landmarks, such as blades of grass or stones. When she returns with a paralyzed fly, she finds the burrow by recognizing the same landmarks. Bembex's tunnel seems relatively simple when we start to compare it with architecture as complex as a spider's web. When a spiderling builds its first web, it is perfect. The spider has nothing to learn, for the entire process is under innate control. The precise building behavior of bees is also mainly innate. The bees are so accurate that different individuals can work on separate parts of the comb, and when all the sections finally meet up, they will match perfectly. The precise building behavior of bees is also mainly innate. The bees are so accurate that different individuals can work on separate parts of the comb, and when all the sections finally meet up, they will match perfectly. Each bee carefully checks every angle so that it measures exactly 120 degrees and tests the thickness of the walls to within 1/100th of a millimeter. This is another digger wasp called Sphex. Like Bembex, it lays its eggs in tunnels in the sand. But instead of continually refilling the nest, Sphex stocks it with paralyzed prey only once, and then she closes the tunnel for good After filling it with sand, she tries to block the tunnel with stones. She's very critical of her work. The stones must fit exactly. Her choice of stones is based on learning by trial and error. At last she's satisfied with her masonry and vibrates her body against the top stone to shake down the sand grains and fill in the cracks. This part of her behavior is believed to be innate. When a young masked weaver builds its first nest, it certainly isn't perfect. The bird has correctly chosen green flexible grasses and split them, but it still has a lot to learn about weaving. It's as though the bird has a blueprint of what the final nest should look like, but lacks the practical experience to achieve it. The weaver bird doesn't require a teacher, it just needs practice. Each stage of nest building automatically stimulates the weaver to move on to the next stage. The final result is recognizable as a masked weaver nest. It's just a bit more untidy than most. These more experienced birds are making a much neater job. It's important that the young weaver should learn quickly, for the male's success at finding a mate depends on his skills as a nest builder. But when man builds, his behavior is guided entirely by skills and knowledge that he has learned. Different cultures and even individual architects build in a variety of styles throughout the species. There is no blueprint. Probably one of the oldest questions concerning learning relates to bird song. Do songbirds have to learn what to sing, or do they know it from the moment they leave the egg? It seems that both learning and innate behavior are important. Many young songbirds must be exposed to the adult territorial song within the first 90 days of hatching, the so-called sensitive period. During this time, the bird will assimilate a crude outline of the song, but it will not sing at this stage. It's only during the following spring that the bird actually practices the song and develops the detailed trills and embellishments which sound so familiar to us. Every species learns a slightly different song, though some, such as jays and starlings, can learn and mimic the calls of another species. Apart from these exceptions, a bird's song is consistent enough to allow us to identify the species, such as this sedge warbler, by its song alone. But no animal behavior is as static as it seems. Even this potter wasp, building its mud nest, must be able to adapt to a constantly changing world.
The history of the Holy Land has been recorded for over 3,000 years. So too has its natural history. Several books of the Bible contain detailed records of the animals that lived in Israel when the Old Testament was being written. There are other records, especially here at the old copper workings at Timnah, known as King Solomon's Mines. 3,500 years ago, Midianite miners carved animals on the rock walls. The drawings are a lively catalogue of the animals that were common in the southern deserts at the time. The white oryx was one, long since extinct as a wild animal in Israel. Another was the ostrich. The ibex was well known to the Midianites. They may have known the addax too, another large desert antelope. In the 8th century, artists made mosaics depicting fallow deer, which have since died out, and wild boar, which is still common in Israel. The boar have been joined on the mountains by gazelles, reintroduced to the Golan Heights after having been wiped out by hunters half a century or more earlier. Nighttime reveals that a number of other species survived the carnage of those days. There are still packs of wild wolves in Israel, especially in the Negev desert in the south. And striped hyenas, though there may be no more than 120 in the whole country. Their prey is often gazelles, especially the Dorcas gazelle, another desert species which has flourished since it was protected by law. But too many animals have gone for good. In 1960, a group of enthusiasts had one of those ideas which illustrates the fine line between genius and madness. They decided to reintroduce into Israel all the animals mentioned in the Bible. They called their harebrained scheme Haibar, which means wildlife. It was to be like a new ark. An old but treasured home movie records the arrival of the first animals in the breeding enclosures at Yotvatah in the Arava Valley in 1968. The first to arrive were onagers, Asiatic wild asses, described by Jeremiah as well used to the wilderness. Next, they released scimitar-horned oryx in order to learn more about their close relative, the white oryx. The animals were released into a large enclosure where they could be fed and watched until their population was big enough to be released into the wild. White oryx finally arrived in 1978. The onagers bred successfully enough for some of them to be released into the desert, while others were kept in a reserve population at Yotvatah. It will soon be time to release more into the desert to join the pioneers. The ostriches mentioned in the Bible disappeared in the 1920s or 30s. These are from the Danakil Desert in Ethiopia, their nearest surviving relatives. Along with the onagers, Somali wild asses, oryx and addax, they roam and breed on the broad plains of the Arava Valley. High Bar Reserve earns its keep by attracting visitors from cities to the north, as well as from Eilat, an international holiday resort at the top of the Red Sea, where the Queen of Sheba landed. The other attraction at High Bar Arava is the Predator Center, where the more ferocious members of the biblical fauna are being bred and studied. Caracals were thought to be extinct until a few individuals were discovered in 1958 in the Negev desert near here. They turned out to be quite common. So too are wolves, which are also being closely studied at the Predator Center. Playing with the wolves is one of High Bar's leopards. About 30 live wild in the Judean desert above the shores of the Red Sea. They belong to a very rare subspecies, which repays close study. There is no plan to release large predators into inhabited parts of the country. However, the animals that were once their prey will be reintroduced. Above the city of Haifa, on the forested slopes of Mount Carmel, a northern branch of the High Bar organization has started on the long road to re-establishing the wild sheep, deer, and wild goats which once lived in these hills. Above them, in the protected forest, there is another rare species which has survived against the odds after centuries of persecution. This is one of the last known nests of the Israeli sparrowhawk. Here, in the reserve, it has a good chance of successfully rearing its young. The woods are not ideal for all the introduced animals. Persian wild sheep brought from Iran breed freely in the enclosures, but the soft ground under the trees is very different from the rocky hills that are their natural home. Their hooves grow too well without the abrasion of rocks. From time to time, the sheep have to be caught and given a pedicure. Staff of the Nature Reserves Authority have a lot of experience in catching these nervous and athletic animals, but it never gets any easier. The general rule is to leave the animals alone so that they retain their wildness, ready for release into the rocky hills when the time comes. But the state of the sheep's hooves was such that they had to be caught. One by one, the staff carry them to a quiet place where they can be treated. The scientists take the chance to check their state of health. In spite of their overgrown hooves, the sheep are all in very good condition. Plainly, returning to the native home of their species has done them no harm. The pedicure over, the slightly flustered sheep is released to regain its composure before being sent back to join its fellows. The ear tag marks it as not needing to be caught in the next drive. Down in the desert, Dawn finds the Yotvatar animals at the height of the breeding season. Addax males fence gingerly with their fearsome horns. It seems remarkable that there aren't more serious injuries. The sparring is ritualized, a trial of strength rather than an out-and-out fight. The ostrich inflates its crop to emphasize the pink neck of the North African subspecies. White oryx fence more energetically than addax, apparently narrowly escaping disaster. Suddenly, a female oryx canters into view. A ragged afterbirth, still not completely ejected, shows that she's given birth within the last few minutes. The hunt is on to find the calf. The best way to find it is to watch the mother. She soon returns to the calf, lying motionless where she left it. From 8 animals brought from America in 1978, the Yotvatar herd has grown to over 50. The only wild herd in the world is in Oman, where they were reintroduced after being bred back from near extinction in one of the most famous conservation rescue exercises. The eventual aim of High Bar is to release part of this herd into the open desert. As soon as she's given birth, the female oryx is ready to mate again. Amorous males gather, attracted by her scent. The calf is at risk in the tense atmosphere surrounding its mother. Males have been known to kill calves at a time like this, but the calf instinctively knows the best way to escape their horns is to lie flat. Its mother is torn between 2 conflicting urges, to mate or to protect her existing calf. For the time being, the calf takes precedence. A lone male waits patiently for the balance to shift in favor of mating. Meanwhile, the ostriches have a brood to rear. The last known individual of the Middle Eastern ostrich was washed away in a flood in southern Jordan in 1966, though the species was practically extinct 30 years before that. These, from the Ethiopian subspecies, come from a desert which is very similar to the Negev, which will eventually become their new home. An oryx calf knows from birth that milk is to be found close to an adult leg. From that beginning, it has to learn the finer details. A male is not productive at either end. When it's challenged by another, it can be clumsy too. Mother is the best guide, and eventually she will manage to show the youngster how to feed. At last, the baby Oryx makes the vital connection, and all would seem to be well. But the males are still interested in mating with its mother. This leads to a dangerous situation which would not arise in the wild. There, species keep separate except briefly at places like waterholes. Here, they're drawn together for long periods at feeding points, and normal relations can become confused with consequent danger to the young ones. With mother's attention distracted by mating, the baby Oryx is left briefly to its own devices. It takes the chance to explore this strange new world. A forest of interesting legs a little way away looks worth investigating. The infant has no way of knowing the dangers of mingling with another species. The addax are curious, but to them, as to all prey animals, anything strange is dangerous. The Oryx reacts as it does to all danger, until the threat passes. It's learning fast. Not even its own species is to be trusted, until it can find the one unthreatening pair of horns, those of its mother. Other mothers with growing calves are indifferent. Even its own mother seems to be engrossed in feeding rather than looking for her offspring. Finally, a reassuring touch shows that the calf is no longer alone. The herd of Oryx has grown well, and it's now nearly ready for release. Some other animals have already gone. A group of onagers was set free in a huge natural enclosure called the Ramon Depression. High Bar have decided to add to their numbers from the stock at Yot Fatah. The earlier release of onagers into the Ramon was almost too successful. It took the rangers a very long time to find the animals again, though passers-by reported seeing them from time to time. These will be marked with indelible numbers so that they can be reported more accurately, even by strangers. An antidote is administered and another onager is ready for freedom. Job was asked, "Who has let the wild ass go free?" Jeremiah noted its adaptation to the wilderness. The wilderness it now inhabits is the spectacular scenery of the Ramon Depression. Bones of wild asses have been found in archaeological digs, but nothing was heard of the species in Israel after those biblical references. It survived in Jordan until 1920, but then it died out. Now it has returned to Israel. Finding the onagers can be a problem. They seem to be able to disappear into the desert without trace. The herd stays together, though there are signs that a breakaway group is forming. This will represent success in the first completed reintroduction of the high bar project. One animal is badly hurt with a broken foreleg, but it'll be left to itself to live or die. Once the animals are reintroduced, they are wild and beyond human intervention. The High Bar project received a severe setback in 1989 when fire devastated the forested slopes of Mount Carmel. The images on Israeli television shocked the country. Trapped in their enclosures, the animals had no escape. Volunteers joined the High Bar staff in fighting the flames, but the damage was extensive. It'll take many years to replace the work lost to the fire. Even while the chainsaws were still clearing the debris, among the ashes of the catastrophe, the animals began to recover. The following spring, all the species being bred at Carmel produced a record number of young. The fallow deer, still scheduled to be the first to be released into the forest, showed little sign of the near disaster. Young males challenging the dominant stags are a symbol that the species will live on down the generations on its return to the home it last knew 1,000 years ago. And now at last the time is coming for the Oryx to be released. The animal once familiar to the Midianites at King Solomon's mines will soon be a feature of the deserts where it evolved millions of years ago.
אל תעלה על החבל. זהו, עמוק, יופי, עמוק, מצוין.
The writers of the Old Testament, the authors of Kings, Job, Jeremiah, and the Song of Solomon, little knew that they were leaving a record for the guidance of their descendants 3,000 years into the future.